Well, let me spend a little bit of time with the course syllabus. I'm going to go back over here to the computer. I won't read through all of these objectives for you, but I would like to just offer you a little bit of an overview of the course, so you have some sense of the direction that we're going to be heading over these next 15 weeks. There are two major divisions for the class. One is related to descriptive statistics, and the other is related to inferential statistics. And as you might surmise, based upon just the two terms, descriptive is just that. We're going to deal with ways that we can describe data which happen to be collected. And we're going to be learning about some ways to organize data, to summarize it, and to describe it. We're going to be dealing with frequency distributions, how we can set up frequency distributions. We're going to be dealing with measures of position or location. Those are percentiles and percentile ranks. We're going to find some measures of average. It's called measures of central tendency. And there are three measures of central tendency that will be briefly discussed. It's the mean, and the median, and the mode. We're also going to determine the variability of scores. When I teach a class on the very first day, like today, I'd like to know something about the students who are in the class. First of all, I like to know whether they happen to be typical of students that I've taught in the past, or whether they happen to be better, or whether perhaps they're not as strong as students that I've had in the past in terms of their understanding of concepts. But even more important than knowing something about their aptitude is whether the students are alike or whether the students are different. Am I dealing with a homogeneous collection of students in terms of their ability, or am I dealing with a heterogeneous distribution? Knowing that's very important because that will influence the way that I approach the teaching of the class. So if they're very much alike, that makes it frankly easier for me. If I happen to have students that are far in terms of range, some that are really very bright, catch on really quickly, and then some students that have been away from math for a long time and are struggling with some of the concepts that are mathematical in nature, then it causes me to go about the process of teaching in a different kind of a way. So we'll deal with variability of scores. There are a number of ways that can be used to describe how variable scores happen to be. We'll also be dealing with the concept of relationships, determining the magnitude of relationships that exist in the world. And we'll be looking primarily at relationships between two variables. So it's like, what's the relationship between the frequency of smoking and the incidence of cancer? What's the relationship between the amount of sweets that you happen to ingest and your likelihood of having a cavity or a carie? What's the relationship between getting no sleep and how well you're going to do on a test? We're going to look at correlations, and so we'll describe what the relationship happens to be between variables. And then we'll also learn how to interpret the relationships, what's possible for us to say and what's not possible for us to say with respect to correlations. You know, just because there happens to be a relationship that exists between smoking and lung cancer, it does not necessarily mean that smoking causes lung cancer. A correlation can never determine cause and effect. It can only suggest that there may be cause and effect. So there are other possibilities, and those must be carefully considered before we take a giant step and assume that one variable happens to cause another variable. Then a little bit into the semester, we're going to shift from descriptive statistics to inferential statistics. And with inferential statistics, we're going to be learning a lot about something that you will be drawing in your notes many times throughout the semester. And that is this. What is that? This is the bell curve or the normal curve. This is a very important concept with respect to inferential statistics. We will find how it's possible in this class to be able to, for a normal distribution of scores, to determine what proportion of all of the scores for this particular distribution happen to fall above this point right here, or what percentage of all of the scores are going to fall between these 2 points in the distribution. So typically we start out with the distribution and we will then provide some information. We will say that the mean for this distribution happens to be 500. And we draw a line over here and we say that this symbol right here is for a standard deviation. And we'll say that the standard deviation happens to be equal to 10. If I know the mean, if I know the standard deviation, then I know that between 490 and 510, that there are about 68%, or a proportion equal to 0.6826 of all of the scores for some distribution that happen to fall. And I know what percentage of all of the scores happen to be above this point in a distribution. So you're going to learn a lot about the normal distribution as time goes on. In fact, you're probably going to learn a whole lot more than you ever wanted to know about normal distributions. But it's an important concept to understand, and we'll be addressing more about the normal distribution as we get closer to that. And then we're going to be doing some studies where we're going to identify some population. And then we're going to obtain from this population a random sample. And we're going to find out something about that random sample. And then after we find out about that random sample, perhaps it's the mean of the sample, perhaps it's something related to the variability of the scores in the sample. We're going to make an inference from the sample back to the entire population. This is inferential statistics. Infer back to the population. We have to make certain that for this random sample that each and every element of the population has an equal and an independent opportunity of being selected. If we don't ensure that, then we're not going to be terribly confident about what we find out regarding this random sample applying to the population. This has worked for a long time. It really does work that we don't have to measure everybody in the population. And in fact, we're getting close to a gubernatorial election in November. And in the state of Nebraska, we'll be seeing some polls. And the polls will not be for all of the voters, but rather for a sample of the voters. For national elections, have you ever looked at the fine print to see about how many people are sampled across the country to reflect what the voting is going to be for the entire United States? Do you know roughly the number of people? Anyone?
1,000.
It's a little bit more than 1,000. Sometimes there's 1,000. Typically it's around 2, maybe 3,000. But it's not a large number. And yet the 2,000 to 3,000 represents, we're talking about millions, right? Millions of people. So with a small sample, we can make an inference to a larger population. And while there are times that we may not be right on to what the number is, usually we come up with a number that's fairly close. There have been some times when we've been off a ways, and in fact, when we get to that point in the semester, I think I'm going to try to show you this time the picture of Harry Truman. Do you remember the one where Harry Truman holds this newspaper up saying that, who was it that won the election?
Dewey.
Thomas Dewey was supposed to win the election. Well, it didn't happen. It was Harry Truman. Harry Truman was the one that won the election. And there was a poll that was taken, and the Chicago Tribune reported that information about Dewey winning because of the fact that that's what the poll said. The poll was wrong. So bad things happen occasionally. They happen in statistics, and they also happen in life, right? So we can't expect that everything is going to happen exactly the way we want it to happen throughout our life. Well, I have provided you with a little bit of an orientation today. We're just about out of time for the class today because I still want to take the pictures. I'm going to continue on from this point in class on Thursday. The class will be here in this room, so please come directly to this room. I would like you, please, to look at the information that happens to be in the first chapter for Graviter and Wool now, and you might as well start reading ahead and start thinking about the second chapter as well, because we'll be starting to deal with that. Once I cover some other preliminary introductory information, then we'll start talking about measurement, and then we'll start talking about symbolic notation, symbolically representing scores.